I welcome you all to the Spark Research YouTube channel. This is Dr. Veer Chandra, Assistant Professor in the Department of ECE. So this is the another series of this GATE 2025 ECE, right? So here we are going to take the questions from this particular course, that is electronic devices. So this is part one only. Let's see. So here is overview. Why are we considering this course? So this is another important course, which is the the from your core subjects only, and mostly the questions may ask in the range of the 8 to 10 marks. So this is one of the important course. So here is the syllabus. You can check it. I got it from the from this website only. Your IIT Guwahati has they is going to conduct your 2026 GATE. So topics are from these electronics devices like energy bands in intrinsic, extrinsic semiconductors, important topics. Then how the carrier will transport like diffusion, drift, all these, like how will it move. So these are the important topics. So let's take the questions now. So question first, this is your, what is the question? So which of the following can be used as an N-type dopant for silicon? So this is a very simple one. Options are also given like arsenic, boron, and gallium and phosphorus. So as per answer key provided by your GATE 2025 attitude key, your answer is A and D are correct. Means arsenic and phosphorus both correct. Okay. So how exactly? So let's see the more detail about this question. So what is question? Actually, here it is asked that how the how can we design the n type of your the n type of material. So that is the question. So exactly you are going to dope some material in the silicon, right? So first question is that what is this n type of doping in silicon, right? So doping means simply you are going to dope, that is you are going to mix something in the intrinsic silicon, right? So if you will dope, that is aid in intrinsic, that will become the extrinsic. So how are we going to dope? We are going to mix everything in the atomic level. Atomic means we are talking about the atoms level. So how we'll know the atoms? So if one atom of silicon have the how many electrons? So this is 14, right? So electronic configuration, where are these electrons? You can found. So 1s2, 2s2, 2p6, 3s2, 3p2. So these are the electrons, right? So total three orbits are there, one, two, three. So third orbit have how many electrons? Total four electrons, right? So that is why each silicon have the the four covalent bond to the neighboring silicon. So that is why this is the pure intrinsic. Now we are going to dope some material. So if we are going to dope, then what will happen? Like suppose if you are going to dope the phosphorus belongs to the fifth group of the 15th group element, and it will have the five valence electrons. So if we will write the electronics configuration for this phosphorus, then what will it be? So it will have the five electrons in the outermost orbit, that is 1s2 and 3p3. So total five electrons. So now, since if you are going to dope the phosphorus in the silicon crystal, so what will happen? Phosphorus, since phosphorus have the five electrons in their outermost orbit, so four electrons will participate to the neighboring silicon to make the covalence bond, but one electron is still extra. And because one electron is moving, so that is why the number of electrons will be high. Means number of electrons, these are number of electrons are free to move in the crystal. So that is why, since the number of electrons are the some numbers of electrons are free in the crystal, I'm talking about the one atom. So if in the crystal thousands of atoms are there, so means much more number of electrons are free to move in the crystal. So since more number of electrons are there, that is why this is called N negative type, right? Because of the presence of the free electron. So actually now question is that the phosphorus belongs to the 15th group. Like phosphorus will have the five electrons in the outermost orbit. Similarly, what are others groups are possible, right? So this is the n type of doping in silicon. So here you can see n type of silicon. Silicon, the phosphorus is going to design the four covalent bond to the neighboring silicon. One electron is extra. So apart from your phosphorus, nitrogen is belongs to the 15th group, then arsenic, strontium, then bismuth. All these elements belongs to the 15th group, right? Similarly, if you wanted to, the design the N type P type of material, in that case, what will we do? We are going to add the elements which belongs to the 13th group. So these are the elements like boron, aluminum, gallium, indium, thallium. So these are the elements belongs to the 13th group. And these are the semiconductor like silicon, germanium. So these are the 14th group, right? So here is the summary. So if you wanted to design your the n type of doping, n type of material, then in that case you are going to add these type of materials which elements belongs to the 15th group. And similarly, if you wanted to have the p type of doping, then in that case you should have these elements which belongs to the 13th group, right? So as per answer key, your A and D are correct. So A is the arsenic and D is your phosphorus. So both belongs to the same group, that is 15. So we can have the N type of doping in this case, right? Okay, let's take one more question. So here question is, the intrinsic carrier concentration of a semiconductor is given, that is 2.5 10 to the power 16 per meter cube at 300 Kelvin. If electron and hole mobilities are given, right, then intrinsic resistivity of the semiconductor has been asked here, right? So very simple question. So here intrinsic number of the semiconductor is given, like how many concentration of your semiconductor is given, and then mobility is also given for both electron hole, and resistivity you have to find out. As per answer key, your answer should be your 1.25, that is B is correct. So let's see how to solve. So before going for solution, so let's understand what exactly the question is. So an intrinsic carrier, right? Intrinsic means the pure semiconductor only. So suppose this is your silicon pure semiconductor wire only, and it contains the some number of the silicon atom, right? So how many numbers? So carrier concentration of semiconductor is this much, 2.5 into 10 to the power 16. So wherever it is telling the carrier concentration, carrier is your electron value. So whenever we are talking about the carrier concentration, it means the number only. We are talking about the number. So this is the number, right? So how many carriers are here? So this is the number 2.5 at temperature is given. Now the electron and hole mobilities are this and this, right? So electron can move faster in the semiconductor, and hole may, the compared to the electron, hole may be the, they may have the less speed. So electron definitely have the faster speed. So these mobilities means the speed, your velocity only, right? So what are the speed? So electron have the velocity of this 0.15 meter square volt second, and then your a hole have this much 0.05, right? Now question has been asked to find out the intrinsic resistivity of the semiconductor. So intrinsic resistivity, right? So how much resistivity, like resistance per unit length. So that we are going to find out. So that is the question. So how much? So how can we find out? So like in your question, intrinsic carrier concentration is given, mobility is also given for electron and hole both. So intrinsic resistivity you can find using the formula 1 over mu, that is a q, that is your charge, and that is the total number of the carrier, and then the speed of the hole and plus electron. So that is mu e and mu h, right? So you can put the values now, all these values, and you can get the answer. So your answer will be 1.25 kilo ohm. So let's see the calculation in some more details. So here are the values. So intrinsic carrier concentration is given, mobility for electron, hole, and the charge already you know, right? Now first find out the, you can find out the conductivity, right? So conductivity, how can you find? Mu and E. Mu is your mu E plus mu H. Once we'll get the conductivity after putting all these value, then you can find out the resistivity, that is 1 over by conductivity. So this is your resistivity. So this is the resistivity, and now we can find the resistivity in per kilo ohm, right? So just divide it by 1000. So final answer is 1.25 kilo ohm, right, per meter. So that's final. Okay, thank you for joining the session. So we'll take the some more question in our upcoming session.